Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Not just a successful data scientist, to become a successful in this field of data science. Okay. Hope you guys are enjoying and learning a lot. We are enjoying and we are learning a lot, and we are just like enhancing our knowledge each and every day. Hope the same thing for you guys. So if you guys have any doubts till this session or whatever the session we are taking, please make sure that you just ping in the comments. We will take up and we will solve your doubts. Okay. So as always guys, before going for this session, please make sure that you guys watch all the previous session videos so that you can have a better understanding of what we're gonna say. So yeah, today's session is on it's a continuation of hierarchical clustering. It's a theory part, that is the black box of hierarchical clustering we are discussing. In the previous session we have introduced you what is hierarchical clustering. Okay, so today we're gonna wrap up this theoretical concept of hierarchical clustering, and we will be moving on to the coding part in the next session. Okay, hope you guys have a proper understanding of what we have introduced you as a hierarchical clustering. Okay, then only you guys can able to understand this. So I will say a glimpse of it. So what is a hierarchical clustering? Whenever you gonna create a cluster in a manner of decision tree like structure. Okay, I will not say decision tree, like a tree like structure, then it is called as hierarchical clustering. It can be top down or bottom up. Okay, let us fix this context, because like if you guys doesn't watch the previous session videos also, let us understand okay what is hierarchical clustering. But like I suggest you guys to watch the previous session video, because like we have introduced you hierarchical clustering where we have uh, like gone through different things like what are the types in hierarchical clustering, what are the linkage factors in hierarchical clustering, how it works, how it related to hierarchical clustering, how the structure it looks like those things we have discussed. So please make sure that you guys watch that video. So see, in simple term, what is hierarchical clustering means? It is like a tree like structure. Now to create a clusters, it can be a top down or bottom up. Okay, both the ways are possible. So without wasting any time, let us jump into today's session. Today's session, we're going to see the dendrogram visualization and interpretation. Okay, I will put it in a simple manner. So like in K-means, we will be using elbow method, right? Guys, this is the reason I'm just asking you guys to just look into all the previous session. If you guys doesn't know elbow method, please make sure that you guys watch the videos related to K-means, where we have discussed you about the elbow method to find the optimal K value. Similarly, we have dendrogram for the hierarchical cluster. Okay, so dendrogram visualization, let us see what it is saying. Height, the height of the branch in a dendrogram represent the dissimilarity between the two clusters being merged. Okay, let us consider this is what dendrogram, guys. Okay, left side you are having dendrogram. If this is called as height, okay, this says this much dissimilarities between the two clusters. Let us consider this is a black cluster, and we are having here it is orange kind of thing, and here it is green kind of. So this height we are having, right? This is called as dissimilarity between two clusters. Cluster merging, when two branches meet, it indicates the merging of two clusters into a large cluster. Okay, so let us consider you are having this is one dendrogram, this is another dendrogram. When I connect these two, it becomes merging of cluster. We are having one cluster here, another cluster here. When I merge them up, then it becomes one cluster. Okay, I will put it in a simple manner. Cluster merging means this is one cluster, this is one cluster, so totally two clusters. Now I need to merge it as one cluster. What I need to do means one cluster, one cluster. So one, two, I'm gonna merge these two. So now it becomes one. Okay, that's it. This is what called as cluster merging. Next, number of clusters. The number of clusters can be determined by cutting the dendrogram at a specific height, resulting in a distinct clusters. Okay, put it in a simple way. Guys, let us consider this is our data set. Okay, entire data set. I'm first cutting it up for the first stage. So it becomes two clusters. Then in the second stage, we are having one, two, three, four clusters. Here two, here two. Next. The next stage, we are having here two, this two, this two, this two. Like you can see, one, two. In the last stage, first stage, we are having one cluster. Second stage, we are having two clusters. Third stage, we are having two clusters. Fourth stage, one, two, three, four, five. Five clusters. And fifth stage, we are having one, two clusters. And sixth stage, we are having only one cluster. And then seventh stage, we are having one. And then here we can say two, like that. Okay, now you guys can able to understand, right? It will be a larger block. From that, from the entire thing, we're gonna segregate it in a manner of a tree. That's it. That is what number of clusters. Okay, just remember guys, height means what is the dissimilarity. Cluster merging means we will be having two different or four different clusters, we will be merging up in order to get a single cluster. Number of clusters means based on the dendrogram and its height, we will just split up into number of distinct clusters. Okay, hope you guys can understand. So this is what the dendrogram visualization and interpretation. Yeah sir, over to you.
Yeah, guys. So, dendrogram visualization and interpretation. There are uh, three, four elements to it. Okay. The first is height. So, what is height? Height you can see here on the graphic. So, from is it minus or what? The graphic is not visible that
Yeah,
much.
yeah, yes sir, yes sir.
So,
It is
you
a
can
cluster.
see here, yeah. So, from minus 0 to minus 6, this is the height. Okay, so you can see cluster dendrogram. Okay, this is how it looks like. Okay, let's go to the concept. Yeah, so there's a height. The height of a branch in dendrogram represents the dissimilarity between the two clusters being merged. This height shows the dissimilarity, okay, of the diagram, okay, of two clusters being merged. Okay, you can see here two clusters being merged, two clusters being merged, then two clusters being merged. Okay, this is how. Then the entire dendrogram is being merged. Okay, then we have step two, which is cluster merging. When two branches meet, it indicates the merging of two clusters into a larger cluster. Right? You can see small clusters, then bigger, then there is interconnection, right? So when two branches meet, it indicates the merging of two clusters into a larger cluster. That's it. Very simple. Then third, number of clusters. The number of clusters can be determined by cutting the dendrogram at a specific height, resulting in distinct cluster. Okay, so that is the number of clusters. These are the number of clusters. Okay, determine the cutting dendrogram at a specific height. Okay, you can see the height, small, bigger, and all. So that is what it is. Okay, so if you have come to this session, go back, watch other sessions, previous sessions directly if you have come. So 5 to 10 times do reinforcement learning, and also watch all the sessions and give us feedback, and have a greater and long-term objective function for your career with patience, persistency, consistency, and perseverance. Okay, learn these skills deeply, apply the information, digest the information, and uh, apply, absorb the information, digest the information, and apply the information. ADA. Okay, so and subscribe to our channels. Also press the bell icon so that you will get notification for each session. Keep learning deeply, guys, with longest, like lifelong learning objective function vision. And let's move to the other section.
Yeah, sure sir, let us move on. Okay, so determining the optimal number of clusters. Okay, so guys, I will say one thing. So in order to determine the optimal number of clusters, we can go for a elbow method also here. Okay, we can go for a dendrogram also. Here also we can use the silhouette analysis, gap statistics. So these are some of the ways where we can find the optimal number of clusters in hierarchical cluster. Let's see. Elbow method is simple. We already know. If you guys have watched our k-means clustering video, then you can easily know. Elbow method. Elbow method analyzes the within cluster variance as a function of the number of clusters. The optimal number of clusters is often identified at the elbow of the graph. Guys, just watch our hierarchical clustering video, theory part, black box of it, and then coding part. You guys can able to understand what is elbow method. We will be having a graph like this, and in the end of the graph we will be having a point as an elbow. So that point you need to take it as the number of clusters. So that will be the optimal number, we can say. Okay, that is what elbow method. Whereas silhouette analysis measures the similarity of data points to its own cluster compared to the other cluster. Higher silver score means it indicates a better cluster. This also we have discussed in coding part. Simple. From metrics we need to import this analysis, and we need two parameters. One is the input of the data set, and another one is output predicted by model. These two things we need, and it should be high. That is what a silver score. It says how much similarity the data points belong to its own cluster when compared to the other cluster. That is what silver score says. Then I think this is new. Gap statistic. Gap statistics compares the within cluster disruption to the expected disruption for the randomly distributed data points. The optimal number of clusters is where the gap statistics is maximized. This is also you to have a maximum gap statistic, that is max value here within cluster disruption. Okay, how it is deviated when compared to the actual deviation we are expected for this random distribution. Based on this disruption, we will identify whether the data points belong to this cluster or some other cluster. Okay, so hope you guys can understand. So these are the three ways where you can determine the optimal number of cluster for this hierarchical cluster. Okay, so yeah guys, that's all about determining the optimal cluster. Yeah sir, over to you.
Yeah, determining the optimal number of clusters. Okay. So we have three concepts here. Understand them deeply at a meta level. So the elbow method analyzes within cluster variance. Okay. As a function of the number of clusters, the optimal number of clusters is often identified as at the elbow of the curve. So that is why you can see that when we have done previous session, there was an elbow kind of shape, and you will find maximum clusters, the optimal number of clusters at elbow. That is what is elbow method. Okay, so like it will analyze within cluster variance of function of the number of clusters, but the optimal number of clusters of the identified at the elbow of the curve. You will find maximum in the elbow. That is why there would be shape of elbow, guys, because you need to make a shape. And normally, if you want to design elbow, you have to have a lot of curves and stuff, right? Angles and all. That is the elbow will only become when there are a lot of joints, right? And then that is why there are the maximum clusters. This is how you can relate. You can see your elbow and see a lot of cartilage and different joints, and then and only, and freedom of expression is there also. There is a freedom, to an extent you can move your elbow, right? That is a mechanics of robotics, but here we are understanding only the elbow. Okay, so you will find maximum clusters at the elbow curve. Okay, second is silhouette analysis, which is a measure of similarity of data points to its own cluster compared to other clusters. So it is only that there should be a similarity. If you are in a cluster, you need to have similarity. Suppose if you are in you belong to a particular religion, you should be doing similar kind of rituals. Okay, so if you are doing similar rituals, you belong to this particular cluster. So I'm just giving one example. You can relate it with other things, and suppose you are eating South Indian food. So people might say you might be belonging South India. You're eating North Indian food. So because you have some similarity, right? So similarly, in cluster silver score analysis, we see this. So measure of similarity of data points to its own cluster compared to other clusters. The higher the silver score indicates better clustering. So the higher the rituals you do of particular sect, you will be considered, oh, he's literally from this particular place or this particular religion or this particular class or this particular ethnicity or stuff. Okay, I'm just giving example. Okay, you can relate, so that you can relate it. And gaps statistics. So the gap statistic compares the within cluster dispersion to the expected dispersion for randomly distributed data points. Okay, so it compares within cluster dispersion to the expected dispersion, guys. Dispersion is what? The spread, dispersed. It is completely dispersed, the spread of the data, right? You can see in the diagram the spread, how it looks like. That's what is dispersion. Okay. Okay. Then the optimal number of clusters is where the gap statistics is maximized. So optimal number of clusters where the gap statistic is maximized. So you can see here in the diagram that the uh, the optimal number of clusters you will find where gap of statics is maximized. You can see gap. Okay, so that is the gap of statistics. The gap between the data is gap of statistics in the spread, in the dispersion. That's it. Okay, let's move to the other section.
Yeah, sure, sir. So, guys, I hope like now we can have a better understanding of what is how to determine the optimal number of clusters for hierarchical cluster. Okay, let's move on. Okay, I hope like now you guys can understand, right? So we're gonna have only two lines of code where we're gonna fix the number of clusters by using dendrogram. Okay, that's the end game. Now you guys need to understand whenever there is a hierarchical system, we need to go for a dendrogram. Whenever we are having k-means, we need to go for a elbow method. Okay, that's the two things that you need to remember. Okay, I will say not remember like by practice you guys can able to understand. But now think now since k-means we need to use a elbow method in order to fix the k value. Whereas hierarchical casting is a tree-like structure where a tree-like structure of dendrogram is used in order to find the best possible k value. Okay, let's see what are the advantages and disadvantages of this hierarchical clustering. Advantage: it is a intuitive and provide a visual representation of cluster structure. It does not require specifying the number of clusters in advance. It is relatively easy to implement and can handle a wide range of data types. Yeah, first thing first, we doesn't need to manually implement the number of clusters because we have dendrogram. Once we give the dataset to the dendrogram, it creates its own number of clusters that it needs. You just need to specify that number which is given by the dendrogram, and it is used for a larger data set. Okay, where the type is kind of a classification. Okay, because like we have a data set, we will classify, further classify. When you are having that kind of data set, that like we will call it as a dvc data set, then this is a better method. Okay, I will say best method when compared to the cluster. When we are having different clusters, right, from that this clustering algorithm is nice. Okay, what is the limitation of this? Hierarchical clustering can be sensitive to outlier and noise in data. It can be computationally expensive for a larger dataset. It is not well suited for handling dataset with a complex or overlapping clusters. True. Okay. When you are having two clusters with similar characteristics, but when it comes to tree, right, you gonna have a root and then two different branches. You cannot say the data points which are present in one branch will have some similarity to the data point which is present in the second branch. Not like that. They should be a properly distributed or like divided into two different subparts where they do not have any communication. That's one problem. Whenever the data set size increases, it needs to go for a very more depth of the dendrogram. Okay, I will say very depth dendrogram we will be getting, so that it is computationally expensive when you go for a larger data set. Then it is well suited, it is not well suited. Okay, it is not well suited for a complex data set. And I have already explained, right, overlapping clusters also not used. Okay, because like it is separate, and complex data set it will give more depth to the dendrogram, so that we can able we are not able to inference from it. Okay, so these are two disadvantages. So I will just again repeat. Advantage: it provides a visual where you can identify what number of clusters are there, and here we doesn't need to priorly in pre-pon, we doesn't need to post the number of clusters that we need. We just say use dendrogram to fix it. That's it. Limitation: Here it is very sensitive, and it is not well suited for a complex problem, because like the depth of the dendrogram will increase and inference becomes very complex, and when it is more data set, it is computationally expensive also. So yeah, these are the things that we are having as a advantages and limitations of this hierarchical cluster. Okay, hope you guys can understand. If you guys doesn't understand, please ping in the comment section. We will take up and we will solve your doubts. Yes, sir, over to you.
Advantages and limitations of hierarchical clustering, guys. So advantages are it is intuitive, it provides visual representation of the cluster structure. It does not require specifically the number of clusters in advance. It is relatively easy to implement. It can handle wide range of data types. Okay. Limitation is it is sensitive to outliers, noisy data. It can be computationally expensive for large data sets. It is not well suited for handling data sets with complex and overlapping clusters. So these are the limitations, which is like you should know in and out of a particular uh, hierarchical clustering. This, like any algorithm, you should know limitations. So these are the do's and don'ts, like what it can do, what it can't do. So advantages and disadvantages. You should know properly for all the algorithms which you are using in data science, AI, ML, or deep learning. So keep learning deeply, guys, at a meta level. Understand the concepts, why and how, why and what and why and how will be a cakewalk. So first focus on what and why. Understand concept brutally, deeply at a meta level. Once you do that, then application is a cakewalk. Okay? Keep learning deeply. Let's move to the other section.
Yeah, sure, sir. Yeah, finally we're gonna have an application, right? For every algorithm we are seeing application. Again, I'm mentioning, since the slide is this much, I'm able to capture 4 different applications. Okay, there are numerous applications. As I'm mentioning, right, all the field which has the application of AIML, then this algorithm is going to be useful. Okay, so first application of this hierarchical testing is customer segmentation. It is used to classify the customer based on their purchasing behavior, demography, or preferences. Can help the business tailor their marketing efforts. Okay, so what is a purchasing habit? Like whether they are purchasing more on the weekends or in weekday. These kind of clusters we can make. Okay, so these are the group of people who can buy the product in the weekdays. Who these are the kind of people who are buy the product in the weekends, like that weekend cluster. Next, document clustering. Clustering text document based on their content can aid in information driven topic modeling and document summarization. Guys, I will put it in a simple manner. When I'm having a book, okay, which belongs to one is A, another one is ML, DL, and another one is data analytics, Tableau, Power BI, something called as a libraries like scikit-learn, TensorFlow, like those things. Okay, to group this, we will say only one name, that is called as data science. Okay, so using these are the documents, we can group it based on only one label, that is called as a data science. This is called as document clustering. It is one of the example I'm just saying. This is how a document clustering works. We will be having multiple documents, and in order to cluster them, we need to find a unique point which can cluster everything or group everything. Okay, this is what called as a document clustering. Moving on, Gini expression analysis. That is clustering genes based on their expression pattern can help researchers identify genes with similar functions or that are involved in the same biological process. Yeah, so gene expression analysis is also very important, so it can group the genes with similar behavior to the similar clusters. Next, image segmentation. Clustering pixels in an image based on their color, texture, or other features can help aid distinct object or region in the image. So consider this is an image. I need to find my face. So I apply the image segmentation that can extract only my face from this entire frame. Okay, so it is called as a region of interest. We only need the bounding box around my face, so you will be focused on only my face from the entire frame. This is called as image segmentation. Segmenting a part from an image is called as image segmentation. Okay, so yeah, this is what all about the application that we are having for this hierarchical clustering. I will not say it is limited. all the field which has the use case of AML will have the application of this hierarchical clustering. So yeah, that's all about from my side. Yeah, sir, over to you.
Application of hierarchical clustering, guys, we can use it in n number of industries. So wherever we require customer segmentation, I'll give a very simple definition to it. So clustering customers based on their purchasing behavior, wherever, and you are able to generate data, demographics, preferences, high business tailored marketing efforts and all. You can use this. So I'll give you example how. You would have known that stat is not today's concept, or mathematics is not today's concept, algorithm is not today's concept. So when there was no data science, machine learning, still big industries used to do this thing only. You would not know, small businesses will not know, but the big businesses had this power. They became big because of these techniques, guys. They became world's billion-dollar corporations because using these techniques. Now it is available to everybody and we are teaching it free. So documentation we can use in any kind of documentation, which clustering of text document based on their content, information, topic, model, summarization. We can use any industry which requires documentation, clustering and all, documenting clustering, right? So there is no limit to it. Any industry who has documentation and wants to do clustering for the text, content, information, model, topic modeling, document summarization, we can use. Then Gini expression analysis, clustering Gini based on their expression patterns, which helps researchers to identify genes with a similar, it can be to biotechnology or healthcare specific, okay? It involves the same biological processes and stuff. You can use Gini expression analysis there in biotechnology and healthcare. Then image segmentation, it again is a specific, it is used for wherever you want to do clustering pixels, images based on color, texture, okay, features which can distinct from the objects, regions in the image, okay. So these are the applications. There is no limit. Wherever there is a scope of these things, you can apply AIML data science. So keep learning deeply and we'll meet in the next session. Thanks.
Yeah, guys, so we will stop here because we have introduced you to the machine, like one of the machine learning concept, that is from clustering, hierarchical clustering. We have introduced a theory concept, black box behind it, what are the mathematical flow of it, and then we have discussed about dendrogram, how it works, how to find the number of optimal clusters, that is k value. So everything we have seen. So yeah, this is all about, we have started what is hierarchical clustering till we have finished application of hierarchical clustering. So we have done with the theory as well as a black box behind the hierarchical clustering. Next session, we're gonna play with the code of hierarchical clustering. Hope you have enjoyed this session, guys. If you guys have any doubt, just ping in the comment section, and we will take up and we will solve your doubts. Okay, that's a promise from our side. Okay, and till now, if you guys doesn't subscribe to our channel, please subscribe to our channel. So because like we are just posting videos each and every day. Okay, so you will be not missing any of our videos, and also press the bell icon so that you will be getting notification whenever we upload a new video. Okay, so yeah, guys, bye, take care until next session. Take care, guys. We will all meet in the next session. Bye, guys.